Pareidolia is a little-known phenomenon that you probably experience almost every day. So what is pareidolia? Pareidolia is when your brain tricks you into thinking that you see something that's not actually there, be it a motion, a pattern, or an image. Our brains instinctively want to see patterns in everything, even if there are none. It's super cool. There are a few different kinds of pareidolia. One of the most common types of pareidolia is facial pareidolia. Facial pareidolia is the term for the human tendency to see faces in everyday objects, be it the surface of the moon, a pepper, or a faucet. Scientists think this occurs because humans are conditioned to be constantly reading emotions within faces, and so we look for them wherever we go. Interestingly, religious imagery is also often the subject of pareidolia. Perhaps it's because we have an instinctive need to justify our beliefs, even if the evidence we're presenting is dubious at best. Or perhaps it's simply because religious imagery is so widespread among some members of our society that it is simply easier for them to pick up on it than other things. Whatever the reason, there seems to be an endless amount of people who have seen Jesus in their toast or the Pope in their fire. Now let's move on to the type of pareidolia that is the subject of my project, motion pareidolia. Motion pareidolia occurs when your brain tricks you into thinking that you see a pattern of movement where there actually is none. We're going to be looking at why and how it happens. First, let's take a look at motion pareidolia in action. For my project, I showed my classmates the following videos and recorded what they saw. Let's take a look at them now. Let's take a look at the results. While we look at them, I invite you to think about what you saw in each of the clips and to compare it to see whether or not you were similar to the majority of people that I studied. We'll start with the initial example from the first video. 12 people saw consistent motion until the end of the video. 3 people saw completely different patterns begin at some point after the original pattern had ended. And only 1 person correctly identified the change from pattern to randomness. Now let's look at the second example from the first video. 7 people saw the alternating right to left motion continue until the end of the video. 9 people saw different patterns begin at some point during the video. And no one saw that the pattern was actually random, or saw the pattern stop at any point during the video. Let's move on to the third example given within the first video. 12 people saw the up and down motion until the end of the video. 3 people saw a different pattern emerge at some point during the video. and only one person saw no pattern at all. And just to remind you, part 2 and 3 of the first video were completely identical and random. Now for a look at the second video. 7 people saw consistent motion throughout the entire video. 6 people saw a different pattern emerge at some point during the video. 2 people saw the pattern stop several frames after it had already stopped. And only one person saw the pattern stop at the correct point. Last but not least, let's take a look at video 3. 10 people saw the pattern continue for the entire video. 3 people saw a different pattern emerge at some point during the video. And 3 people saw the pattern stop, all of them several frames after the pattern had actually stopped. In all of these clips, the majority of people either saw the pattern continue on until the end of the video, or saw a new pattern emerge at some point during the video. Even in the 2 random and identical videos, 7 and 12 people respectively saw the pattern that they were told to think about continue until the very end of the video. Very interestingly, even when people correctly perceived that the pattern had changed, they were unable to tell that it changed to random and instead sought to assign some different pattern to the random flashing static noise. Only in 2 instances was someone completely correct about when the pattern stopped. All of this means that even today, humans are predisposed towards seeing patterns where there are none in a variety of situations, which could have a variety of effects on our personal lives. So why does this happen? The answer is that there are a lot of reasons, but the 2 that I'm about to talk about seem to be the most important. The first is that evolution helped push us towards this path. As humans evolved, we need to use our senses to analyze our surroundings to ensure our safety. If we saw, for example, this shadow moving behind the bush, it would be safer to assume that it was some sort of distinct pattern that could lead to a direct harm to us. It was more beneficial for our brains to assume that these motions were patterns and to predict the outcomes of these patterns, because that is the way that we could ensure our safety. If our brains didn't have this built-in predisposition towards seeing patterns, it is likely that we would have been less successful in avoiding harmful elements in our environment. However, in the modern day, this leads to us being predisposed towards seeing patterns that aren't actually there. The second element that pushed you towards seeing these patterns was confirmation bias. The messages before the clips, specifying what kind of movement you should look out for, trigger your brain to be on the alert for this kind of movement, and therefore you are more susceptible to seeing it, even if it's not actually there. Your brain is being primed to see certain kinds of motion. Motion pareidolia is a fascinating illusion that works by tricking your mind into seeing something that isn't really there, using your own evolution. Now there's only really one real question left. Should we be worshipping this pancake? Thanks for watching.